Excellent. Well, a very warm welcome to you all. My name is David Kelnar. As John mentioned, I'm an investment director and head of research at MMC. Our goal is really to identify emerging areas of value creation, and that includes new technologies like machine learning and blockchain, to understand those very deeply, and then to identify and invest in the very best early stage companies in that space. It's a pleasure for me to speak to you this morning about the important and I think exciting subject of artificial intelligence, as in conjunction with our friends at Numis, we launch our inaugural State of AI report for 2017. Now, AI has been described as the ultimate breakthrough technology by none other than the CEO of Microsoft. And 5 of the world's 10 most valuable companies are now repositioning themselves to become AI-first organizations. Now, while hype around AI is clearly at a peak, and while I think results will sometimes fall a little bit shy of some of the loftiest expectations in the short term, I do believe that AI represents a paradigm shift in software that actually warrants the attention it's receiving. And in 2017, AI reached an inflection point driven by new milestones in capability, in applications, in adoption, and in entrepreneurship. I'd like to share with you today 5 highlights from the report. I'll begin by providing an accessible introduction for the non-specialist to the question, what is AI? Because although virtually all of us have heard of AI, most of us won't have had the opportunity to understand the basics of what AI technology is. I'll then describe the proliferation in applications of AI that we've seen during 2017. I'll touch on some of the profound implications that AI will have, from shifts in sector value chains through to the obviation of old business models and the creation of new ones. I'll highlight a shift in adoption that we've seen as AI crosses the chasm from innovators and early adopters into now the early mainstream. And I'll finish by talking about some of the dynamics we see in the UK AI ecosystem, a second wave of entrepreneurship. So let's begin. What is AI? Well, coined in 1956, AI is actually a very general term that just refers to computer hardware or software that exhibits behavior which appears to be intelligent. Now, intelligence comes by degree. And actually, we've had basic AI for decades via simple rules-based programs that exhibit rudimentary displays of intelligence in specific contexts. Meet Prospector. Developed in the 1970s, Prospector is an example of an early form of AI called an expert system. And the idea behind an expert system was to mimic the way that a human approaches solving a problem. So what we do with an expert system is codify in software a body of knowledge together with a set of rules, an inference engine. And by combining those two, the goal is to emulate how a human approaches a situation. Now, in the case of Prospector, Prospector was designed to mimic the way a geologist assesses the viability of a drilling site. Now, Prospector did actually have some successes, discovered some new molybdenum deposits in Washington state, but broadly the results from these expert systems, this early form of AI, and progress in the years since, was pretty limited. Why? Well, ultimately, most real-world problems, from optimizing the operation of a complicated industrial asset through to making a medical diagnosis, are just too complex to be solved by computer programs following sets of rules written by people. The data sets are too broad, the variables are too numerous, the relationships between those variables are just too complex. But what if? What if we could transfer some of that burden of writing intelligent software from a programmer to her program? That's the promise of modern artificial intelligence. And excitement and progress, the reason we're talking about AI today is because of a newer field of AI called machine learning. Machine learning is a subset of AI. All machine learning is AI, but not all AI is machine learning. Now, with machine learning, for the first time, we give computers the ability to learn instead of them being explicitly programmed with what to do. And how do we create computer programs that can learn? By creating computer programs that have the ability to improve through processes of training. So with machine learning, we can take our machine learning algorithm, we provide inputs, usually in the form of training data, whose correct outputs we actually already know in advance. We specify the variables that we want the algorithm to consider, and then using a variety of statistical and mathematical techniques, depending on the flavor of machine learning we're using, the algorithm will then weigh those variables to make a prediction or an output. We can then compare that output to what we know it should be, and if it's wrong, the machine learning algorithm can adjust how it weighs those variables. Now you can imagine the first few times you run a machine learning algorithm, you get pretty lousy results. But as we input thousands of training examples and run thousands of cycles of training, the machine learning algorithm becomes better and better tuned to the point where the results it provides can be highly accurate. And at that point, we can take it out from the lab and stop using training data and apply it to real-world data and hopefully get very powerful predictive results. Fraud detection is a really good real-life example of where machine learning comes in useful. It's incredibly difficult to write a set of rules that will identify all and only the correct cases of credit card fraud. But with machine learning, we can feed in vast amounts of data about buyers, about vendors, locations, and a lot more, and give the machine learning algorithm the task of how best to weigh those to more accurately catch instances of fraud and avoid false positives. Now, even with the power of general machine learning today, there's still a range of problems, particularly recognizing objects and images, translating languages, and much more, that are still too difficult for us to solve. Why? Well, in those cases, we can't actually even specify the features of the data that we want the system to optimize in the first place. Dalmatians or ice cream? It's really difficult to write a computer program that will identify pictures of dogs in all and only the correct cases. Why? Because I can't write a set of rules that specifies the visual appearance of a dog in a way that will work in all and only the right cases. Dogs, of course, come in all different shapes and sizes, different colors. Their orientations in pictures can differ. They can be partially obscured. Even if I could somehow write an exhaustive set of rules to describe that, it wouldn't be a scalable solution. I'd need to write a different set of rules for every type of object I wanted to recognize. Enter deep learning. Deep learning has electrified the world of artificial intelligence, machine learning in recent years. And it's delivering breakthrough solutions, particularly in areas of computer vision and language. Deep learning is itself a subset, a type of machine learning. All deep learning is machine learning, but not all machine learning is deep learning. And with deep learning, we go a step further. We offload even more of the burden of creating intelligent software from the programmer to her program. We offload not just the task of feature optimization, but even of actually identifying features in data in the first place. How does it work? Details are in the report. I don't quite have time to cover it today. But suffice it to say, it is delivering breakthrough results in actually a broad range of areas, but particularly including computer vision and language. This is how an autonomous car sees the world. And this is made possible using deep learning technology. You can see the car identifies other vehicles, pedestrians, and as it approaches a junction, it recognizes traffic lights and more. Now, in 2017, we achieved new milestones in capability around AI technology. Just to give you one example, earlier this year, Microsoft released the latest version of its speech recognition capability based on a lot of deep learning algorithms. And the so-called word error rate of that algorithm was 5.1%. Now, to put that in context, human-level word error rate on a similar task is about 6%. So for the first time in human history, we've now achieved meaningfully, statistically better than human results for speech recognition. What's fueling some of these developments? Well, firstly, new algorithms, convolutional neural networks, recurrent neural networks, generative adversarial networks, all these various different new varieties of machine learning, and particularly deep learning that we've got, are giving better and better results, often from slightly smaller data sets. But also we've seen an exponential growth in the training data that's necessary to train these machine learning algorithms. Now, think about it, most data today touches the internet at some stage in its journey. So looking at volume of internet data provides a very rough proxy for how humanity's production of data is tracking. Now, in 1992, humanity was transferring about 100 gigabytes of data per day. By 2020, we'll be transferring 61,000 gigabytes per second. That exponential increase in the availability of data has transformed our ability to train machine learning algorithms effectively. And finally, investment. There's been a 10x increase in venture funding in AI over the last few years, from $500 million to about $5 billion, and actually a bigger increase in investment, many billions of dollars, from the world's leading technology companies today, and all the companies you will have heard of. And as a result of the confluence of all of these factors, for the first time, AI technology really has come of age. So, let's recap so far. We've seen that AI just means intelligent software, but that the value comes in machine learning, teaching computers to improve through training instead of following sets of rules. Now, one of our findings is that AI is not a solution looking for a problem. It's a useful, enabling technology that's unlocking scope for revenue growth and cost savings for companies today. There's been a proliferation in applications, in use cases of AI over the last 12 months. And we describe 31 core use cases now for AI across 8 different sectors in the report. Why have we seen this proliferation of application? Why is this such a broad-based enabler? Well, at heart, AI tackles a profound range of technical challenges, and solutions to those challenges have application in virtually every area of human endeavor. Since the 1950s, AI research has progressed along 5 broad fields. The first is knowledge, the ability to represent knowledge in software. The notion that there are certain entities in the world. Those entities have certain properties and certain relationships to one another. Secondly, reasoning. Teaching computers to use the kind of deductive and inductive and abductive reasoning that as humans we take for granted. Thirdly, planning. Teaching computers to recognize that, okay, there's a certain state of affairs in the world today, a certain different future desirable state of affairs. How do we move from one to the other? Perception has been another large area of research. Teaching computers to understand and respond to visual and other stimuli. You saw that with the case of autonomous vehicles. And finally, language, the ability for computers to recognize the written and spoken word. Now, it'll be apparent that breakthroughs in any one of these 5 areas, let alone the progress we've seen in all 5, will have dramatic implications. These are just some of the new possibilities at a high level that machine learning is making possible. If we can better encode knowledge in software, we can have new possibilities around medical diagnosis and the personalization of retail experiences. I'll talk a bit about that in a moment. Around reasoning, we can augment and perhaps automate some of the work we do in, for example, legal services and asset management. If we can get computers better at planning, we can improve our physical and digital networks, improve our logistics capabilities. We can teach computers to see. We usher in the era of autonomous vehicles and have implications for surveillance. And if we can teach computers to recognize the written and spoken word, we usher in a new era of voice-controlled devices, virtual assistants, chatbots, and more. But I think those points hide a simpler but deeper truth, which is that today we live in an information economy. And the ability to process information more intelligently means that machine learning has application in every sector and virtually every business process. That said, its impact will not be even. We think there are a range of sectors where AI will have a greater impact than others, and that's usually sectors where a greater proportion of time is spent collating and processing information. About half of people's time in finance or more is spent doing just that. So I think you'll see a huge impact of machine learning and AI in financial services. But beyond that, all of these areas, retail, transport, manufacturing, healthcare, more than a third of people's time is spent managing information. Contrast this maybe with other sectors or other professions like teaching, where there can be a higher proportion of unpredictable manual work or a little less data intensity. I want to just highlight a small number of use cases that we've seen proliferating over the last 12 months in 4 sectors. In the world of retail, AI is ushering in the era of personalization. The growth of e-commerce, now 17% of retail sales in the UK and growing fast, together with the digitization of retail data, has resulted in an explosion in the breadth and the depth of data available to retailers about their customers. And retailers can use machine learning to improve virtually every stage of their engagement with consumers, starting with customer segmentation, then through to content personalization, then price optimization, and finally even churn prediction. I'll highlight just a couple there. Content personalization. The reality is that online conversion is still really low. It averages 1% on mobile, 2.7% on desktop. But the reasons for that are pretty obvious. The reality is we're just not presenting goods and services to people that are usually particularly relevant to what their actual individual needs are. But with machine learning and drawing on some of those computer vision and language technologies, we can improve that. We can look into people's social media profiles, learn more about their preferences. We can draw on computer vision and offer them, for example, goods that are more likely to be in the kind of color palette that we know they like. As a result, you can drastically improve the relevance of what you're showing. Price optimization is another big win that can be had and a proliferating use case we've seen. Traditional rules-based software is quite limited around what enables you to do around price optimization. We tend to price goods usually based on maybe a cost-plus model or relative to competitors or other fairly crude metrics. But the reality is an individual's propensity to pay can be an enormous driver of value and of revenue. With machine learning, the ability to draw in broader data sets, for example, taking into account the entry of new product lines or the end-of-lifing of products, together with the ability to find more subtle patterns in data, means that we can optimize pricing much more efficiently to increase revenue per user. In the world of manufacturing, so-called overall equipment effectiveness, OEE, is a measure of manufacturers' productive output relative to potential. And OEE is still surprisingly low. Median OEE in a range of sectors can be as low as 75% in what is a hyper-competitive global manufacturing environment. Machine learning has a lot of useful use cases here. Predictive maintenance is one. For every hour that an automotive assembly line goes down due to equipment failure, the cost to that manufacturer can be £1.5 to £2 million. It's an incredibly expensive situation. But with machine learning, we can take data from sensors embedded in machines, find subtle patterns in that data that are suggestive of leading indicators of equipment failure. We can then predict with quite a high degree of accuracy when a machine or indeed a component is likely to fail, and we can proactively swap out that component in advance and avoid that hour's downtime, saving millions of pounds in the process. Asset performance optimization is another great use case. It's really difficult to write a set of rules that will optimize, let's say, the flow of fuel into a gas turbine to the microsecond in such a way that will maximize productive output while minimizing environmental emissions and wear and tear. That's a very difficult problem to solve. But with machine learning, we can apply deep learning and broader machine learning techniques to find, again, more subtle patterns in data and weigh these variables more effectively. And you can find you can improve the output of these assets by more than 20% with relatively modest effort in relation to machine learning. And that's millions of pounds worth given the scale of these industrial assets. I'll finish by just touching on a couple of final sectors. One is asset management. AI's ability to synthesize data and the world of machine-to-human interaction it enables via chatbots has myriad applications in asset management. Investment strategy is a particularly powerful area. We can use machine learning to better synthesize data from within and beyond a firm. And we can then find more subtle patterns in that data to undertake better multi-objective optimization. So how do you maximize, say, deployment of capital and returns while minimizing risk or volatility? Very difficult to write a set of rules to do that. Machine learning can do it better. And in client service, the rise of chatbots is helping transform what companies can do, both when deployed internally and beyond companies. Within a company, a chatbot interface can enable an account manager to really effectively query the status of a client's account or the impact of an external event on that account in seconds instead of minutes. As a result, for the first time, we'll be able to offer the kind of level of service that previously was reserved to high net worth individuals to the mass affluent. And when deployed beyond a firm, chatbots can be useful for clients to discover information about products, to sign up, for client self-service, and more. And finally, in legal and compliance, you think about AI's ability around knowledge and understanding. That clearly has myriad applications here, particularly around document review and behavioral analysis. The average M&A data room nowadays has 33,000 pages of information in it. At best, it's going to take a vast legal team a long time to go through that. In reality, they will prioritize, points will get missed. With machine learning, we can ingest that data into a machine learning system and better identify aberrations for what are normally accepted baseline terms or other red flags. Now, the point here is probably not to replace the staff doing that, but it will significantly augment and target their work. So which of those 33,000 pages do they perhaps want to be looking at first? And around cybersecurity, I think cybersecurity will be one of the defining issues of our age. And it's very difficult to have rules-based programs that are effective at cybersecurity. And that's very simply because the nature of cybersecurity threats keeps evolving, keeps changing. But with machine learning, we can establish baseline levels of activity on a network or around individuals, and then in real time, in a way that's not possible with a human team, catch aberrations from that baseline that might indicate a problem. So, we've seen there's a proliferation in AI use cases over the last 12 months. But let's talk a bit about what I think is actually most important, which is the profound implications that AI will have over the years ahead. Now, to understand the implications that AI will have, I think it's helpful just to first abstract and understand what are the core benefits of AI. Because if we really understand those benefits at the highest level, the implications become a little bit easier to see. I think you can abstract the benefits of AI at the highest level to these four. Innovation, new products and services, making the previously impossible possible. So autonomous vehicles, for example. The second benefit is efficacy, the ability in some cases to perform tasks more effectively than we otherwise could before, so fraud detection. Third benefit is velocity, the ability to undertake tasks more quickly than what's been possible in the past through increasing automation. And finally, scalability. Because we're enabling computers to do for the first time what were traditionally human capabilities, we break free from the kind of scalability constraints that were possible in the past. And that gives new possibilities like automated medical diagnosis. Now, when we think about those four benefits, innovation, efficacy, velocity, and scalability, I think the implications start to become a little clearer. A first is new market participants. In a range of sectors, from healthcare to financial services, those sectors have only been accessible historically to subsets of the global population. Take access to primary care, a GP, in the world of healthcare. In the West, talking to a GP is expensive and an inconvenience. And in developing economies, access to primary care is often non-existent. Why? Well, fundamentally because medical diagnosis is delivered by experienced professionals. Training those professionals takes time and money, and because they're humans, their scalability is limited. With limited supply comes high cost and limited accessibility. But with the age of machine learning, we can have automated medical diagnosis, at least of a wide range of conditions in the short to the medium term. The marginal cost of diagnosing a patient using machine learning algorithm will be zero. And accessibility is not going to be a problem either. By 2020, about 60% of the population of Africa, for example, will have a smartphone. The combination of dramatically reduced cost and increased access will result in an influx of new market participants in a range of markets from healthcare, financial services, and more. And that will have, I think, profound implications both for society at large, but also for the companies servicing that need directly and the ecosystems around them. A second big implication is shifts in sector value chains. And by that, I mean where and the extent to which profits are available within an industry. Take insurance. 42% of all insurance revenue of any kind globally is from car insurance. Yet, in the years ahead, we'll see the rise of autonomous vehicles. And alongside the rise of autonomous vehicles, we'll see a decline in the frequency and severity of car accidents. Alongside that will come, therefore, a reduction in the cost and the price of car insurance. In fact, it's forecast that the profitability that insurers will achieve from car insurance in the UK over the years ahead, that fall will be more than 80%. How will the insurance industry adapt when it stands to lose 80% of its profitability from 40% of its revenue? And I think you'll expect to see similarly profound shifts in value chains in most sectors. Thirdly, shifts in companies' competitive positioning. Every paradigm shift in technology destabilizes incumbents and creates new winners. And I think AI will be no different. In the age of AI, I think you'll see the emergence of four kinds of companies: platforms and disruptors, and leaders and laggards. Among suppliers of AI, you'll see platforms and disruptors. Platforms are companies like Google, Amazon, IBM, Microsoft, the so-called game vendors, GAIM. that provide the infrastructure and machine learning services that power a lot of the AI ecosystem. I think those companies are very well positioned to accrue value in the years ahead. But those companies don't have the strategic desire, the data advantage, or domain expertise to tackle the myriad vertical applications and use cases where AI can help. And that's where the disruptors come in. And the disruptors are what we call the early stage companies that have AI at the heart of their value proposition. And as a venture capital firm, it's the disruptors that we aim to back. I think to incumbents, these disruptors will be a double-edged sword. Disruptors will enable incumbents who have the vision to embrace them and use them as suppliers, but I think they will disrupt the incumbents that don't. Now, among those incumbents, among buyers of AI, I think you'll see a bifurcation emerge into leaders and laggards. Leaders will be the companies that have the right success factors for the age of AI. They will have the organizational vision to embrace AI, and more importantly, the organizational ability to actually deploy it. They will have large non-public data sets to give them an edge in training their machine learning algorithms. They'll have the ability to attract and retain and integrate data scientists and affect the other changes to their personnel that will be necessary for success. They'll affect a mindshare shift from deterministic software to more probabilistic-based answers and recommendations. Companies that do all of those things, I think, will strengthen dramatically their competitive advantage in the age of AI. And they'll take advantage of two particular effects. Firstly, we live in this information economy, and companies that can process information more intelligently, I think, will accrue a disproportionate amount of economic value. But secondly, they can take advantage of data network effects. The more data you have, the better your results. The better your results, the more clients you can attract. The more clients you attract, the more data you get. That's a virtuous circle. It's very difficult for other competitors to break. We can contrast those leaders with the laggards. Laggards will lack the vision, or probably more realistically, the organizational ability to deploy AI. They'll lack those kind of capabilities I described. And ultimately, I think you'll find they lose market share and relevance surprisingly quickly. To me, what's really interesting about new technologies is not so much the new technical capabilities they enable. It's the new business models they make possible. I think the combination of AI plus subscription business models plus X as a service that we've been seeing will obviate a range of old business models and create a lot of new ones. In particular, I think we will see a transformation in the economic fabric of, for example, transport, particularly car ownership, and insurance. Take transport. Cars spend 96% of their lives parked and unused. That's insane. But it's been necessary historically because cars have been the only way to achieve the kind of point-to-point convenience, the privacy, the security, the spontaneity that people need. But with the rise of autonomous vehicles, we'll see the creation of optimally distributed fleets of autonomous vehicles available on demand from your smartphone. The cost of a marginal journey using that network will be very low because we've not only removed the cost of the driver, we've also amortized the cost of the fuel in the vehicle across a vastly higher number of journeys over a given period. I think you'll see the emergence of transport as a service, where we'll pay a low monthly fee, who knows, perhaps £49.99 per month, for all-you-can-eat access to an on-demand autonomous vehicle service, basically autonomous Uber, but on a subscription model. That will clearly have seismic ramifications for the industry. A decline in private vehicle ownership will result, but also there will be downstream implications from that change in business model. Local repair centres, local petrol stations, all of those business models are going to need to change as you have the rise of large, centrally managed out-of-town fleets. I'll finish by just touching on the benefits and risks to society in terms of the implications of AI. I think the benefits of AI are tremendously exciting and valuable, I think relatively easy to understand. We'll have better healthcare, we'll have more accessible transportation, we'll have increased industrial and agricultural output and more. But so too there are risks around AI, and I think we need to have an open and mature conversation about those in the months and years ahead. Some of those risks include job displacement, concern around entrenching prejudices that we've had for decades into the next generation of algorithms, concerns around privacy, and the rise of autonomous weapons. I'll just touch on one today, and that's job displacement. There are a small number of roles, including truck driving and telemarketing, that AI will directly automate. Those roles employ a lot of people. There's 3.5 million truck drivers in the US alone. Now, if we look at UK census data from about 1870, we see that declines in employment in some sectors, like agriculture, as a result of automation, have been more than offset by the rise of new jobs or the refocusing of the economy into other areas. And there is a debate in AI about whether AI will create more jobs than it destroys. I don't know the answer to whether or not it will. My concern, though, is that whether or not AI creates more jobs than it destroys in the long term, the short period of time in which quite a large number of people's work could be displaced, and a narrowing of the base of similarly skilled roles they could undertake, could prevent that group from being reabsorbed into the workforce in the short term. And I think social and ultimately political consequences can follow. And I think what we've started to see over the last couple of years has been some of the concerns from people globally who have started to feel like they're being left behind by the impact of globalization. I'll talk finally around a tipping point in adoption. Interest around AI has increased dramatically over the last 12 months. Amazingly, in 2016, AI didn't even feature in the top 100 terms searched for by corporate executives on Gartner.com. But by the middle of this year, AI had become the 7th most searched for term overall. Now, more importantly than interest is actual action. McKinsey undertook a brilliant survey. They talked to 30,000 AI-aware executives across 30 countries. And what they found is that 1 in 5 companies have now deployed some form of AI, either in a core part of their business or at scale. In our view, AI appears to be crossing the chasm. We're no longer just at the stage of the innovators and the early adopters. We're just in the early stages of moving to the early mainstream, the early majority. And I think you'll see that trend accelerate over the next 36 months. 3/4 of companies plan to implement AI to some degree over the next 3 years. Now, adoption of AI is not even, interestingly. This is an excerpt, this is the top right of the chart, if you like, of data from that same McKinsey survey, showing on the x-axis companies that have the highest current, sectors that have the highest current level of adoption of AI, and on the y-axis, their propensity to spend on AI in the future. And there's a couple of things I'd point out. Firstly, what you're seeing here are the sectors that are the early adopters of AI. And what do we find? Well, it's led by financial service firms, high-tech, telco, automotive and assembly, and more. But secondly, what's really interesting is that it seems like the sectors that are embracing AI most aggressively today are also the sectors that are planning to spend more on AI in the future. In other words, there is a bifurcation emerging. There is a group of sectors like the ones on this board that are both early adopters of AI and increasing their spend on it most in the future, versus some other sectors like retail in the middle of the pack and areas like construction, which are at the other end of the scale. And it's all very well saying companies are deploying AI, but what does that actually mean? What kind of AI? And what you'll find is, although there's a lot of attention around chatbots in the business press, the reality is, and there is, by the way, plenty of activity around chatbots, most companies are, I think, very sensibly deploying AI for where it's really most impactful for the business, which is better decision-making, recommendations, if you like, revenue growth, and process automation for cost savings. I'll finish today by highlighting the final trend that we saw, which is a very powerful second wave of entrepreneurship in UK AI. There's about 400 AI startups in the UK. That's early stage companies with AI genuinely at the heart of their value proposition. We've met so far about 250 of them. There's a few trends I'd highlight. The first is that activity is flourishing. The number of new AI startups founded annually in the UK has doubled in recent years versus prior to 2014. In fact, since 2014, a new AI startup has been founded in the UK on average every 5 days. Secondly, we're undergoing a shift now. The first wave of AI investment and entrepreneurship was really around AI research, so companies like DeepMind, and also, companies focusing on core AI technologies, computer vision, language, horizontal technology enablers, if you like, applicable to most sectors. Today, we're firmly moving towards the second wave of AI entrepreneurship, the age of applications. And while there'll continue to be fantastic platform work being created, 9 out of 10 of all of those 400 companies are now B2B software providers addressing a specific need in a sector or addressing a specific business process. Now, the focus of those companies is highly uneven, interestingly. We've heat mapped where these companies are focused by function and by sector. And by function, what we find is that 1 in 7 of all of those 400 companies are focused on marketing and advertising. There's also a substantial focus around IT, that's particularly knowledge management and discovery, and around BI and analytics. By sector, 1 in 10 companies, more than any other area, are focused on finance. And then there's been an influx of new healthcare companies as well. Why are entrepreneurs focusing on marketing, advertising, BI, finance, healthcare, and retail? It's for really smart reasons. All of those sectors have large data sets, ripe for machine learning training. They have numerous prediction and optimization challenges that are very well suited to machine learning technology. And critically for entrepreneurs, they all offer a tangible ROI, the ability to say, okay, I increased your conversion by X% or I saved you Y. And as a result, given that most of these companies are selling B2B, it's very important to help entrepreneurs get scale and validation in the market. We shouldn't underestimate, though, that the UK AI sector, and indeed the global AI sector, is nascent. 3/4 of all of those AI startups are at the very earliest stages of their journey with seed or angel funding. Now, interestingly, those companies, although early, are nonetheless a little less nascent than their European competitors. So European AI companies on the continent are earlier still, so it might be a slight advantage for UK companies in procurement situations there. The combination of all of these factors, the huge amount of activity in new companies, the shift to the wave of applications, is creating, I think, unprecedented opportunities for entrepreneurs, for the people who work at those companies, and for investors. How do you pick the winners? Well, we've got an investment framework, which I won't go into now, but we detail in the report, which describes the 16 success factors that we think are key for applied AI companies. We divide those into the areas of value potential, value realization, and defensibility. So we hope that serves as a bit of a useful guide for what we think will matter for these companies in the years ahead. So let's sum up. We've seen that AI just means intelligent software, but machine learning is software that learns through training. And what is the state of AI 2017? Well, we've seen a proliferation in applications. We've seen the early days of some of the profound implications that we'll see for AI, those shifts in sector value chains and shifts in business models. We've seen that in 2017, AI started to cross the chasm of adoption from innovators and early adopters through to just the very early stage of the early mainstream. And finally, we've seen this second wave of entrepreneurship, the age of applications. I'll leave you with one final thought. Historically, industrial revolutions have focused on the creation and transmission of power or of communication. So the first industrial revolution, steam power, was about the mechanization of production for the first time. 100 years later, electricity enabled mass production. 100 years after that, the electronics revolution of the 1970s onwards has enabled the mass production of production and indeed communication. Today, though, we're entering the fourth industrial revolution. And that's the age of information. And in the age of information, our primary source of value creation comes from our ability to process information. And ultimately, it's AI's ability to process information more intelligently that I think will yield benefits both humble and also truly historic. Thank you.